Let's do a bit of recap. Start with. Quiet down. Trent.
Seven. I can't speak. I was seven.
Oh, sorry, Seb. Sorry, Trent. Seb. No, that's recorded. Okay, here we go. Let's revise what we learnt last session. Let's start off with Finn. What does this mean again? What's the -2 to 1? What is that telling you?
That means that it's between -2 and 1, but it doesn't include -2.
Good. What is including and what isn't included? What does it describe? What's the name for this again? The name for this. The -2 to 1 is representing something. There's a name. What's the name again, Charlotte? No, parabola is the equation. The function is a parabola, but what's the -2 to 1? So yes, you're right. It doesn't include -2, but does include 1. So what includes -2? What is including 1? What are we talking about? Are we talking about skies? Are we talking about money? Including -2? What is it talking about? Points on the graph of which specific point? Specific. When you do a coordinate or a point, you've got two things that are involved. What are we talking about, Lucy? The domain. What is the domain again, Seb?
Possible x values.
Yes, possible x values. So, write in your notes if you've forgotten, this is called the domain. What is the domain? The domain is what x coordinates that this graph can take. Okay, so yes, you're right, there is a parabola. Yes, you're right, it is a set of coordinates. But what type of coordinates can you take? -2 to 1. But for what? See, a coordinate has an x and a y value. This only tells you that x can only be between -2 and 1. So on the x-axis, what you already have is it only goes from -2 to 1. Okay, so I'm just going to draw it over here so it's bigger. -2, sorry, over here. -2 to 1. Okay, so this is your x-axis. The only values you can have are between these points. You can't have anything beyond 1, you can't have anything before -2. Okay? This is called your domain. Maps onto R. This means that this group of numbers is on a set of axes where they have numbers. Okay, so R is your numbers. Now, listening. We said it's a quadratic equation, x squared plus 1. What does that look like again? So reading the graph, you've got an x squared and a plus 1. What does the plus 1 do again? Goes up by 1. Now, this is a parabola. Is it a positive parabola or is it a negative parabola? Positive. So we know it's a smiley shape and it goes up by 1. Now this is what the graph would normally look like. Goes up. Goes up 1. So you got your turning point. Goes up by 1 and it's a parabola. True? So it keeps going. It goes on infinitely and infinitely. So if I just rub off this side here, what you have is you got a quadratic equation where it continues on. Okay? Now this is x squared. This is an x squared plus 1 graph. What's the problem with this graph? We said it can only be between -2 to 1. Okay, so we want to only have between -2 and 1. We don't want everything. We don't want when x is all the way out here and all the way down there. We don't want that. We only want between -2 and 1. So when they ask you to sketch this graph, you're still sketching the graph, but you cut it off at -2. Comes off at 1. So how you draw it is if you know x can only be at -2 and 1. So let's think about it. When x is -2, how do I find the coordinates? I know x is -2. How do I find the y coordinate? At this point, how do I find the y coordinate? What do I do? If x equals to -2, what should the y value be at that point? Sub it into what? Fantastic. Into the x where the function is. So your function, you're saying if I sub in -2, you want to know what the y value is. Now -2 squared, which gives you 4 plus the 1, which is 5. Correct. So I know at this point it's -2, 5. Now we already just said, or Finn said before, that at -2 you don't include the values. I'm using an open circle there. Okay? Boys. At negative 2, 5, we don't include that point. But then let's look at x equals 1. Where would the y value be of x equals 1? So when x equals 1, where would the y value be? So when x equals 1, y is? Let's work it out. 2. F of 1 means you sub 1 into the equation. 1 squared plus 1. 1 plus 1 is 2. So now I know at 1, I've got a coordinate. So I've got the endpoints now. I've got negative 2, 5, 1, 1. So when I sketch the parabola, it's exactly the same shape. The only difference is I only take part of it. Whoops. I only take a part of it. Okay, so if you want to sort of understand what I'm saying, I'll draw it over here so you can see at negative 2 and at 1, instead of drawing the entire graph, I only get, sorry, 1 should be over here. 1 should be about here. So at this point, you've got 2. Over here, you got 5. So the graph should only be this part of the section. You see what I'm doing there? I only draw open circle at negative 2, closed circle at x equals 1. So at x equals 1, this is only the part of the graph I draw. I shouldn't have the red part. It shouldn't look like that. So if I rub that off, this is all you sketch. That's what this means. So you're saying I'm restricting the graph only between negative 2 and 1, but you still have the same graph. I only draw a portion of it. Okay? So if I change that domain, then it changes which portion of the graph you want. Okay? How do we feel? It's all right? So that's just a recap of what we did last session. Reading domain, reading the range. Now today's session, we're going to talk about a function again. How do you know if something's a function again? What do you do? How do you know if something's a function? The? Yeah, what kind of line?
Straight line.
Straight line down or straight line across?
Down.
Down. That's called a vertical line test. If the line goes down on a graph and it crosses only once, then it is a function. If it crosses twice, it's a relation. Now, the tip that I gave you for that session was that if you had a graph that looked like this and you did a vertical line test, you can see there are 2 points that it intersects there. These are 2 y values for the 1 x value. That's why in the machine that I mentioned, that if you put in 1 x value, you don't want 2 different y values. That's not a function. That's called a relation. Okay, so this is called a square root relation at this point. Today's lesson, you're going to learn a one-to-one function. So not only have you just learned how do you determine if something's a function, now you can determine is it a one-to-one function. Okay, so the question is, what is a one-to-one function? This is what I want you to copy down. Copy down these 3 graphs. A one-to-one function, so now you know what a function is. A function is when you only have 1 y value. But there are different graphs that can have 1 y value, but they look very different. And so I'll show you the quadratic equation versus the linear equation. These are the 2 ones that you've learnt in year 9. This is not a one-to-one. This is a one-to-one. What a one-to-one means is for every x value you put in, you only get 1 y value. An example would be like this. So I'll show you a machine. Here we go. What's a one-to-one? If let's say the equation was a straight line equation. Let's say I gave you f of x equals to x plus 1. That's a straight line equation. Now why is this a one-to-one? Think about it. If I chuck in x equals 1, you sub in 1 in, 1 plus 1 gives you y equals 2. See, when you put 1x, you get 1y. That's why it's called a one-to-one. Now, why is a quadratic equation not a one-to-one? Let's have a look. See, if I put the quadratic equation as x squared, and I put in x equals 2, what's 2 squared? 4. So it spits out a y value of 4. But at the same time, if I sub in x equals to negative 2, what do I get there? 4 as well. So what you can see here, this is not a one-to-one. Why is that? Because 2 x values give you the same 1 y value. A one-to-one means for every x, you only get 1 unique y. See, if I sub in x equals negative 2 into the linear equation, you get a different y value. They're unique. This is called a one-to-one. This is called a many-to-one. to 1 is there many x values to get the one y value. Okay, so I'm just going to do it over here just so you can see the comparison. If I subbed in, this is your function y equals x plus 1. If I subbed in x equals to 2 and I sub in x equals negative 2, what you'll see is you get two different y values. You get either 3 or you get negative 1. See, for every x value, when I sub in 2, I get 3. When I sub in negative 2, I get negative 1. Every x has a y, but there's their own unique y. It's almost like a relationship in a way, but you know, if you've got a partner, then you've got one partner together. Whereas this one is sort of saying, for one partner, you've got two different partners there. Okay, so 2 boys to 1 girl, or that kind of thing. So this is a many to one, or 1 to 1. Monogamous relationship. Okay? 1 to 1. I know what that is. That's polyamorous, whatever the word is. Yeah.
What about the parallel ones?
Oh, good question. Yeah. Now, that's a good question. So now we understand what a function is. A function always says you get one y value for every x you put in. So these two are functions. But this is called a many-to-one function, whereas this is a one-to-one. So what about this graph over here? Okay, so let's think about the coordinates. When I says y equals 5. Now, if this is the equation y equals 5, then if I told you at x equals 1, what's the coordinates here? What would that be? If the equation's y equals 5, if I chuck in an x equals 1, what the y be? What the y coordinate be here? So thinking about it graphically, don't think too much over it. If the machine was y equals 5, which is this graph, and I said at x equals 1, if I put it into this machine, what would the y value be here? 5. Because that's what the formula says. It says y is always 5. See, if I ask you the coordinate here, you'd say it's 1, 5. If I ask the coordinate over here, you'd say 2, 5, 3, 5, 6, 5, 7, 5. Those are the coordinates. Now, what's the problem with that? If I sub in 1, I get a 5. If I sub in 2, I still get a 5. If I sub in 3, I still get a 5. What kind of function is that? Is that a one-to-one, or is it a many-to-one, or is it not a function? It's a many-to-one, because it's polyamorous. Yes? Because it's y, which is 5. 5 is connected with x equals 1. 5 is also connected with x equals 2. 5 is also connected with x equals 7. It has many relationships with different variables. Whereas a one-to-one is monogamous. In the sense that x is 2, then it's only for 3. These two are only connected, no one else is going to have 3. Whereas x equals negative 2 is only paired with negative 1. They don't change. That's a one-to-one. So a linear line like this one, all the x values have only one y value. So that's a one-to-one here. This is a many-to-one. This is also a many-to-one. Because you get many x values for the one y. Now, if all that sort of gets a bit confusing, then very similar to your vertical line test, you have a new test that you can do to find out if it's one-to-one. I want you to write that one down. Horizontal line test. A horizontal line test will tell you whether you have a one-to-one or not. You see, in this example that I got, in those 3 examples there, if you did a vertical line test, it just tells you whether it's a function. So if I do vertical line crosses once, vertical line crosses once, vertical line, yes, they're all functions. But what kind of function are they? See, now I can say, by doing a horizontal line test, I can do green. That crosses twice. That's not a one-to-one. This crosses once. That's a one-to-one. This crosses infinitely. It's a many-to-one. Okay? Yes, Finn?
What about a... What about a cubic? Because it's only some of them are unique.
Good. See, a cubic that looks like that. What kind of shape would this one be? So it is a function. If I do a vertical line test, whoops. If I did a vertical line test, it is a function. That's why it's a cubic function. It crosses once. But if I do a horizontal line test, what would this tell me? Is it a one-to-one or is it not a one-to-one? Not a one-to-one. Because it makes sense that when I do a horizontal line test for this one y value, it's paired up with 3 different coordinates. 3 different x values that can get the same y value. But then for some cubics, you can have a cubic graph that looks like this. That's a one-to-one.
But if you like measure, if you do the horizontal line, but like the other.
No, it has to be for the entire graph because the function is the machine, so it will take all values. So all values, not a single point. Yeah. As soon as you have one point where it has two of them, then it's no longer one-to-one. Yeah. Does that make sense? So today's lesson is to revise what a function is, which you learn when you do a vertical line test. If you have more than 2 points that it crosses, it's a function, not a function. Today's lesson is, if you do a horizontal line test and it crosses twice or crosses more than once, then it is not a one-to-one. Okay? Because a one-to-one you always want that for one x there's a one y. You don't want many x's to one y. Okay? Now, let's try this example. So just like the other one, these are functions. If I asked you if these are one-to-one or not one-to-one, what do you think you'll be looking for this time? What's it? Same x will tell you if it's a function. So there's no same x's, so it is a function, so same y values. Why is that? Because you want to find out which different x values can get you exactly the same y's. Remember that. It's sort of like, if I'm the y, you don't want to find me with another partner. I only have one, I shouldn't have another one. It'd just be me. So it's the same thing with the y value. If it's a 4, you shouldn't be seeing another 4 somewhere. If you see another 4, you see this 4 is paired with a 1, and this 4 is also paired with a 3. This 4 here is not a one-to-one relationship. 4 is currently being paired with 1 and 3. That is when it's a many-to-one. Okay, so this is a many-to-one, not a one-to-one. So what's the tip? You look for repeated y values. So write that down somewhere so to remind yourselves. Repeated y values will tell you it's not a one-to-one. Okay, that's what I want you to write down. So unlike the one that you did in the last session, if you have repeated x values, it is not a function. Whereas now it's repeated y values, it is not a one-to-one function. Okay, so those are the two things you just learned to say. Okay, so make sure to copy that down, because in the next slide we're just going to do some examples just to revise everything again. Domain, what a function is, range, sketch the graph, determine if it's a one-to-one or not a one-to-one. That's all you're doing. Okay, and then in D you're going to put them all together, draw different graphs in one, and then we're almost done with chapter 5. Yep, many-to-one. Many-to-one is when you have 2x for the one y. Yeah. Or when y is polyamorous. Yeah. Okay, here we go. Now, let's have a look at question 2 here. Let's ask each and every one of you here. So, question 2I. Is a function or not a function, Will? It is function. How do you know if it's a function or not? What test would you do, Lauren? Vertical line test. If it crosses once, this will tell you it's a function. Okay? But then if you do a horizontal line test, it's not a one-to-one. Okay, next one, B. Listening? B. Hamish, is this a function or not? No, this is a relation. As soon as it's a relation, you don't need to say it's a one-to-one or not. Because part B, you can't have a one-to-one function if it's not a function to begin with. It's a relation. So you can scrap out part B, state which of the graph is a one-to-one function. This is not, because it's a relation, not a function. Next one. Is C a function or not a function, Ben? It is a function. When I draw a vertical line test, it crosses once. In this particular case, if I do a horizontal line test, it also crosses only once. So not only is it a function, it is also a one-to-one function. For every x, there's only one y value. Okay? Next one, what about D? Is this a function or is it not a function, Oscar? It is a function. Vertical line test shows it's a function. But what type of function is this, Anne? It is a many to one. Doing a horizontal line test, you can see for one y there are two x values. So that y value is not being faithful. It's not monogamous. Yeah, it's got two x values for the one y. So this is a many to one function. Next one, E. Is this a function, not a function? Yasmin? Not a function. So therefore, you don't need to work out if it's a one-to-one or not. Okay, because this is a relation. Is it a relation? What about F? Is this a function, Simone? Yes, it is. What type of function is this, Steph? For F. It is a many to one. During a horizontal line test, it crosses multiple times. Therefore, it is a many to one function. So this is a many to one. Let's go to G. Is G a function, Trent? Yes, it is. Is this a one-to-one function? Let's go with Anna. Yes, it is. When you do a horizontal line test, my line's a bit bad there, but it crosses only once. Therefore, it is a one-to-one. So this is a one-to-one. And finally, H, is this a function or not, Matt? It isn't. Vertical line test shows that it is a relation, so therefore you don't need to work out if it's a one-to-one or a many-to-one function. Okay? Oh, sorry. It says not one-to-one.
It says not one. Oh, I see.
Yeah. Not one-to-one. Okay? There you go. So today's lesson was just to work on that. Otherwise, each and every one of the exercises, just getting you to do what I showed you in the first example. Sketch the graph, but then want you to restrict it so that you have two one-to-one. So I'll do this example, and then you can do exercise 5D. 5D, here we go. Let's sketch the graph first. What kind of graph do I have here? Can I please have, let's go with, oh no, I've chosen Seb. What kind of graph do I have right now? It is a function, but what kind of function?
Parabola.
It is parabola, quadratic function. Now you got x squared minus 2. What does the minus 2 tell me, Finn? Down by 2. And parabola, is this a positive function or is it a negative function? Let's go with Hamish. Positive. So I know it's a smiley face and it goes down by 2. So this is what it looks like so far. It goes down by 2. That's my turning point. That's my graph. But is this a one-to-one function? It is a function. But is this a function or is it not a function? Can I please have, let's go with Olympia. Is 7, the graph that I just sketched, x squared minus 2, is this a function or not a function? It is a function. Now what type of function do I have there, Rachel? What kind of function is that? Is that a one-to-one or not a one-to-one? It is not. It's a many-to-one. How do you know? Do a horizontal line test. You can see it crosses twice. Now that's a problem. What the part B is asking you to do is you want to write a domain. Okay, so what x values that this graph can take so that you can change it to a one-to-one. Because right now it's not a one-to-one. Now how do you make this a one-to-one? Where would be the cutoff point? Where can I make sure that it will stay one-to-one and it doesn't become a many-to-one? So how do I change this polygamous relationship to a monogamous relationship is what I'm asking. Okay? How do we do that? Cutting down at 0, because if I sketch the left-hand side, if I just did this, it's the half side of a parabola, but look at that, that's a one-to-one. So if you do a horizontal line test now, it only crosses once. Whereas if I sketch the other side of the parabola, that's a one-to-one. You put them both together, it becomes a many-to-one. So what the question's asking you to do is what's the domain that I can have? It's clearly from negative infinity up until 0, which is the turning point. When x is 0, that was the last point before it goes back up again and repeats. So at the turning point, this is where I have a one-to-one. So how to answer the question? You would say when x is a part of or is an element or a member of negative infinity to 0, or you can have x element of 0 to infinity. So I'm just saying you can either have from 0, x is starting at 0, to positive infinity, and you only sketch that part of the quadratic or the parabola. That will make it a one-to-one. Well, you sketch from negative infinity up to 0, that will make it 1 to 1. But if you sketch it from negative infinity to negative infinity, that's not 1 to 1 anymore. So your job is to figure out where would you have to cut it off to make it a 1 to 1. Okay, that's part of the sort of skill 5D. Okay, so you know what a function is, you know what a 1 to 1 is, what a many to 1 is. Your job is to change the domain. So everything that you want to learn is reading that integral notation, how to change that. Okay. Any questions so far? Because that's all you're doing for exercise 5D, and that's what I want you to start on for today. And then I'm calling up the students who promised me today to show me your work. And those who can't, will be detention after school today. Yes, your name is one of them too.